Let me show you. This is basically red. Here is a wood to substitute that. It's stronger than this and higher. I need to do some adjustments here. It's easy. But first I need to remove this wall to let me install this one here. Made adjustments that is really easy and fast, and then I can put the floor in place. Let's do it. As this piece of wood now will be higher, I need measure here, I need check here to let me cut a little bit this wall, and it's okay. I removed the wall, but I find out that the wood here will be higher, and I made a cut on the wall to let the wall adapt on this new piece of wood. Just that, a little bit more work, but need be done. About the decision of the solar charger controller, we choose for MPPT, but have another technology on the market, PWM. But what is the difference about both technologies? The first technology for solar controller was really simple. Just a automatic switch. When the battery voltage is lower than the setup of the controller just switch the solar panel to the battery. It's a simple switch, a relay. And all the current of the solar panel goes to the battery. And when the wanted voltage on the battery is achieved, the controller switch off the solar panel and done. And this technology have a very low efficiency and makes some problems to the battery, because sometimes the battery overheating or the lead acid can boil. That is not a good idea. The second technology that is derivated from the first one, the simple switch, on, off, need more energy, on, the voltage is okay, off, that is PWM. And what this means? Simple. Or not. It's really simple. It's not so difficult to understand. PWM means pulse width modulation. Means it's a modulation of the energy changing the time of the pulse or the switch. Thinking again, the old technology is just a switch. You need energy, switch on. You don't need the energy, switch off. PWM is almost the same thing, but the switch is on off every time, all the time. Typically the frequency is really high when you turn on or turn off. But think, just to try to explain, if you turn on, the frequency is 1 a minute. You turn on every minute. The time that you turn off depends the amount of energy that you want to send to the battery. Like, if I want to send just 50%, I turn on 30 seconds. A minute have 6 seconds. Every 6 seconds the switch will turn on. To turn off 30 seconds means I will have just 50% of the energy going to the battery. If I want 30%, 30% of 60 seconds is 20 seconds. You turn on every 60 minutes, and if you want 30% of the energy, you turn off with 20 seconds. Let me try to explain a little bit about PWM. The frequency is fixed. The amount of time that the switch is on is something that we change to change the amount of energy that we want to send. Let me try to explain you, okay? Every time that I clap my hand, the switch is on. Every time I want off, I just move out the hands. Let me try to show you. The strong click is the first time, okay? Is the main frequency. On and wait. On, okay? Can you understand? On. 100%. If I want the full power, I just turn on and keep there. On. On again. That is the full power, okay? I want 50% of the power. On. Off. On. Off. Means the 50% of the time the switch is off. If I want 25% of the power, okay? Again, on, off. On, off, wait. On, off, wait. 75% of power. On, off, on, off, on. That is the main idea of PWM, okay? It's just that. And what is the switch? Well, the PWM system cannot work with relay because the frequency is too high. It's a transistor. It's just a transistor. And talking in a simple way, the transistor is a switch. Have some more concepts inside, but it's a simple switch. But it's not a switch that you go down there and switch on or switch off. The switch of the transistor is depends, have many types, but is energy. You put a voltage in one of the terminals of the transistor, and the transistor turn on. You remove the transistor, turn off. That is the main concept, okay? And transistor have no mechanical parts and can work with high frequencies. That's why this system, PWM or MPPT, use transistors. I hope I did an explanation that is able to understand.
I don't know if I can understand.
That is the main idea. It's really simple. But the frequency of the switching is really high. Typically, depends the technology, is typically more than 5, 10, 20, 15,000 times per second. And with these, the battery voltage is almost constant when you switch on and off. If you spend too much time on, the voltage grows too high. With high frequency, this doesn't happen. This works better than the old technology, but this technology has some issues. For some use, it's the best thing because it's simple, it's cheap, it's light, and it's smaller. To keep the engine batteries with full charge is the best option because you don't need really a lot of energy. It's just to keep the engine start battery with full charge. You don't need high efficiency, you don't need a lot of energy, you don't need a higher ability to control. It's just to keep the battery full charge. But if you want high efficiency, that is not the best technology. And that's why the MPPT arrive. Let me show you. This is a typical controllers, MPPT and PWM. You can see this is a 30 amps MPPT and this is a 80 amps MPPT. We are talking now about almost 3 times more current capacity than the MPPT. But PWM is simple, it's lighter, but it's not the high efficiency. Very smart, a chamfer to have more power to handle with weight. Nice. Let me give you an example of our cockpit solar panel. It's 155 watts or watts, and it's about 18 volts and 7.5 amps. When the PWM switch, we have a voltage drop 18 to 12, 13, 14. Think that the battery is not full charge, is about 13 volts, okay? The drop is about 5 volts. It's 18 to 13. But the solar panel cannot increase the current. If you have a voltage drop, the current doesn't get higher. A little bit, but not too much, because the limit of the solar panel is about current 2. Cannot send more current than is the standard. Means the solar panel will not send 155 watts. That means that 155 watts solar panel, when they have a 5 volts drop, will produce about 98 watts. We are losing almost 60 watts just because the controller are not able to handle with this voltage drop, and we are losing this energy. All this energy is just not in use. That's why PWM is good for engine start batteries, or batteries that doesn't need a lot of energy. It's not high consumption systems like engine battery starts. This is the original wood, and this is the new one. Okay, what I do, I need cut a little bit because it's a little bit longer. Can you see that? I need cut this amount here to be able to. Man, it's difficult do this kind of job and hold the camera. Okay. Okay, here. Okay, here. It's good to check if it's okay. As I have the amount that I need cut this side, now I need make the line to do the chamfer. Yes, it's okay. Here is okay, and here, okay, here, okay, here, okay, here again. Chamfer here. Chamfer here. Now I do the same line the other side to be sure that I'm doing the right way. Okay, let's check. Man, perfect! In the first try. Let me try this. I think it's perfect. Okay, that is the worst part of this adjustment. Now it's just easy parts. Now, the beauty. The MPPT charger controller. The first thing that I have inside the MPPT, the base of the MPPT is the same of the first technology, a switch. And this switch works like the PWM controller. It's almost the same thing. It's a switch with a high frequency, changing the time of the pulse, the amount of time that energy is sent to the battery, but have another special thing inside that can, the right expression is not that, but I think it's simple to explain, it's simple to understand. The MPPT have a kind of converter that can convert voltage to current. That's it. The main idea, okay? When we have in the MPPT charger controller 18 volts input coming from the solar panel, an output of 13, in the same example that I did with the PWM, we have the 5 volts drop. But MPPT can change these 5 volts to something about 3.5 amps, something like that. Means the solar panel send 18 volts with 7.5 amps, and MPPT send to the battery 13 volts with almost 12 amps. The power of the solar panel, 155, goes directly to the battery. We don't lose anything. We are talking about a lot of energy that we are using with MPPT and we are losing with PWM. But we need pay a lot of money because it's much more expensive and is bigger and heavier. We need pay for that. Well, it's our decision. It's a good idea when you need high efficiency, when you need a lot of energy. Then you have a system that can handle with that, can bring a lot of efficiency to the system. And the last thing, some cutting here to adapt this wall, and now I can check if the floor is going right, and then put the batteries in place, and then I can put the floor and organize the boat. And another week or another time I will start to do the installation of the battery. I mean the electrical part of the battery. 10 first batteries is in place. Yes, 10. Look here. 1, 2, 3, 4, 6, 7, 9, 10. I did adjustment here, adjustment here. That was the plan. Everything works as the plan. Now I install the floor and see if everything is right. Okay, floor it's in place. When we will work to change the floor here, I have a finishing to install in this place and another here in the middle. The finishing is ready, is there, waiting me just to install, but we'll do this when we change the floor finishing, because the height can change a little bit and it's better do later. But the job is done. Now at almost 5 p.m. time to lunch. I'm hungry. Think like this. The water tank there is my solar panel. The water pipe is the wires. And the controller, the PWM controller, the switch, it's here. And I need fulfill another water tank, okay? If you think on PWM, every time the switch turns on, the tank that I need to fulfill will receive a high pressure water flow that will splash everywhere. And all the pressure that comes, part of this pressure we don't use. The energy that is inside we don't use. Like this. You can see comes a lot of pressure. The water splash in the outside and splash water everywhere. Almost the same thing happens with the battery. When the switch turns on and off all the time, the battery receives a high pressure, a high voltage every time. That is not the perfect way to charge the battery, because the perfect way is with a continuous voltage, a continuous current, and with PWM the battery receive a high peak of voltage and amperage, that is not perfect. The lifetime of the battery will decrease a little bit, okay? But with MPPT it's a little bit different. MPPT, this is an example more or less how this work with MPPT. We have another thing on the output of PWM that makes a constant flow of voltage and amperage and not high peaks. That helps to convert the voltage to current, like I told you, and helps to not have the peaks because it's a constant flow. Let me give you this example. You can see the flow is constant even when I turn on and turn off, and keeps flowing. More or less it's like this happens on MPPT. Plus the system that tracks the maximum power point of the solar panel. Okay, that is another thing. But more or less it's like this on PWM and MPPT. I hope you guys understand this, because that is the decision. Well, to be honest, when I faced for the first time the solar system, and the first time I studied solar system for this boat, to be honest, about 5 years ago. I spent a lot of time to understand the technologies and everything, and the first thing I faced was this: PWM or MPPT. No one give me a easy explanation about that. I made a long research. Luckily I studied electrics. My father was electrical engineer. My grandfather was electrical engineer, and this helps a lot to understand what is happening inside, because I like to know what is happening inside the systems, the controllers, to make my decision. And I made my decision. That is clear to me, and I hope I'm clear enough to let you guys understand my decision, and hopefully if someone needs to make the decision for yourself, I hope I can help with that.